Hello SGD. This video will be on what's generally referred to often as harmonics. So the question is, what is harmonics? So I'll be talking about harmonic numbers, how they apply to many fields, but through geometry and all architecture, but again, weights and measure systems, very ancient, very modern. So what is harmonics? Well, I can't give you a concise answer for that. Let's look at what it applies to. Good way to think about harmonics is with these what's described as the most harmonic numbers. And so really just begin with two rows. So 2, 4, 8, 16, 32, etc., which is 2 to the first, 2 squared, 2 cubed, 2 to the fourth power, 2 to the fifth, etc. Then running across the top, we have 3, 9, 27, 81. So 3 to the first, 3 to the second, 3 squared, 3 cubed, 3 to the fourth, so 2, 4, 8, 16, 3, 9, 27. And then we just multiply them, so 2 times 3 is 6, 2 times 9 is 18, and etc. So that's where this chart comes from. And in there's quite a bit of info. Now, there are other ways, but for instance, 4 to 3 ratio, as in the 3, 4, 5 triangle. So the Vesica Pisces, like this fundamental, it's literally Prop 1, Book 1 in Euclid's Elements. So it's Euclidean geometry, essentially. I've mentioned in many other videos, even though it's my channel name, I don't like the term sacred geometry because it gives people a woo factor to it. But it's built based on Euclidean geometry to begin with. Now, there are non-Euclidean geometries in there, but the true laws of geometry, sacred geometry, should be in lowercase sacred, bold capitals geometry. Without the geometry, then it's just sacred, and then that can mean anything to any person. But geometry is geometry, and this is the Vesica Pisces, 2 circles with the center of the first on the edge of the second. Now that's let's begin with the first two numbers of harmonics, 2 and 3, the 2 to 3 ratio. So this is one way to apply to it. Now, we'll be coming back to this, but for instance, Pythagorean tuning, you might have heard about 432 versus 440. But here we have the idealized Pythagorean tuning. Some people like 431.5, but 432, firstly in the number sense, is quite nice. But in this chart we have like 256, 192, 288, 432, 324, 486. So these are all Pythagorean tuning, as it's called. Now, what's important to note is that the 3 to 2 ratio, or 2 to 3, for perfect fifth in music theory, is the ratio between these. So C256 divided by 192G is a 3 to 2. 192 to 288 is 2 to 3. 2 to 3, 3 to 2, 2 to 3. So that geometry will be an important feature that's in regards to music. Now, another way to think about these harmonic numbers is time. Now, for instance, there are 24 hours per day, and orders of magnitude, so 36 is not 3,600. Okay, but orders of magnitude, which is detractors like the tens, the hundreds, and the thousands, but that's an important. Anyway, 60 minutes per hour, 60 seconds per minute, 24 hours per day, 1,440 minutes per day, 86,400 seconds per day, 864, and 3,600 seconds per hour. So these numbers have a nice reflection in regards to a breakdown of time. Now, that's measurement. Think of another measurement as the compass, or the 360 degrees. So there again, each degree is made of 60 minutes per degree, and each minute of the compass is 60 seconds, so 6. Now we also have 360 degrees, so again the 36, or why is this? Or 3,600 seconds per degree. The same thing that's happening with time, 60 seconds per minute, 60 minutes per hour or per degree, which means the compass is of 21,600 minutes in a 360 degree compass, 216, and there are 1,296,000 that should be seconds in the compass. It's not minutes, seconds, but anyway, typo there. But time, degrees. Now back to the vesica. Inside the vesica you have this diamond shape, which is really nice in regards to the square root of 3, but the angles that make this up, for instance 240 degrees is 14,400 minutes, or 864,000 seconds, so 24 hours per day, 240 degrees, 14,400 minutes in that angle, which is 1,440 minutes per day in time, which is 86,400 seconds per day, and that's 864,000. So all of the sort of angles that make up the vesica, so whether it's the external angle of this rhombus or the internal angle, again 60, which breaks down in the same sets of numbers now. So the 2 to 3 ratio of a vesica, with geometries, the angles built in there, the square root of 3 and other features that you can extract from there. So it also will apply to architecture. Now let's start with Durham Cathedral, which has a tower 144 feet high, and the central tower, I'm not sure, there's probably a better name for that architecturally, but that's 216 feet or 144 cubits. 1.5 feet equals a cubit in most scales, not all of them, but that in itself will lead you to a 2 to 3 ratio. So 144 to 216 is a 2 to 3 ratio. You'll see this built into the sacred architecture across the world, still being used now, but quite an ancient tradition. Now that's just one example. The Manitoba Legislative Building has the same, so the height to the width of the building includes this, what's the Hermetic constant, as it's at Hermes, this ratio of 2 to 3, which is very musical, the perfect fifth. Actually, this is out of order, but anyway, Bode's law. Okay, we'll cover that later. So we come back to Pythagorean tuning, the vesica Pisces 2 to 3. Again, like with these harmonic numbers beginning 2 and 3. Now, a more ancient example of this practice would be in the Parthenon. I've done a whole series on just this building, but also how it connects to Indian architecture as well. And this is Anne Balkan's analysis, where she goes through the area of each room compared to the whole, even the volumes. It's just a mathematical masterpiece, and the harmonic numbers are just all over it. It's not just 2 to 3 or 9 to 4 or the 4 to 3 ratio. It's just a anyway. But you'll see that although the ratio of 9 to 4 is a proportion that is most visible, so length to height and width to length is again, each part of a building, the whole or all the small parts, always come back to these harmonious proportions, very lovely geometric proportions. So the ratio most visible within the Parthenon, the ratio of 2 to 3, the musical fifth. And again, I've dealt with that in a long video going through each of the features, areas, and yeah, it's just all over the place. But 3 to 2, again, like the vesica. Now, although the ratio is 9 to 4, okay, so 9 to 4 and a 2 to 3, but think about that 9 to 4. So 3 squared is 9, 2 squared is 4. So the proportions of areas, the proportions of dimensions such as height, width, and length, all incorporate this. Again, this was built into it very intentionally. It doesn't happen by accident. No, and that each of those numbers themselves are very specific. 48, which is a harmonic. Yeah, but that went on for hours looking at that series. But back to the 2 to 3. So where else does it? For cathedrals. Classical architecture, Greco-Roman, but now think about the Pyramid of Khafre, which is the middle pyramid of the three, the Giza Plateau. That is 3 wide by 2 high, which is the vesica ratio, and also will lead to the Pythagorean theorem, because because it's naturally cut down the middle, and that gives you a 3, 4, 5 triangle. So Pythagorean tuning, Pythagorean theorem, the 3, 4, 5 triangle. Now, it also applies not just to the pyramid of Khafre, it's also a wonderful connection between other pyramids. Now, for instance, the Red Pyramid is 3 wide to the height of a Great Pyramid being 2. When you look at the pyramids, the essence of the geometry is not just in each individual one. I've done some videos on this as well. It connects them all. Red Pyramid, Bent Pyramid, Maidum, Great Pyramid, and all of these others. And now, for instance, okay, the Khafre Pyramid, that's the one with the casing stones on the top with the Sphinx right in front of it. Okay, so the Pyramid of Khafre up there, where we see the angles, and it's made of 2, 3, 4, 5 triangles. So if we go down to Thebes, I'll come to that in a moment, because those in previous series I went through these individual temples looking at the alignments and stuff, so I'm not going to cover that in great detail. But this is an example. Think of Khafre's pyramid as a template which describes so many others. So Giza Plateau, and then we come down towards Abu Sir and these other places where these other pyramids are. Okay, Pyramid of Pepi II, 150 cubits wide by 100 high. That gives us a 2:3 ratio. Merenre as well has the same proportions but also the same dimensions. Pepi I, same proportions, same dimensions. Teti, same proportions, same dimensions. These less ones. So the Khafre's pyramid is larger, but these other pyramids I'm showing you all have the same proportions, but they also repeat the same measurements of 150 wide by 100 high. That's in Egyptian royal cubits. Userkaf has the same. Neferakare has the same. Ameni Komai, now that one's a little bit more difficult, so I've got a question mark there, but so this 2:3 ratio of a Vesica Pisces is just everywhere, and also the angles that produces with the 3, 4, 5 triangle. We see that in the series I did when I looked at Thebes, for instance, but also at Abydos, where the Osirion and the Temple of Seti I is. The angle at which it is aligned is the same angle as Khafre's pyramid, which creates that same proportions as well. So it's not just the building height to width. You'll find it in the actual layout of these temples themselves, the grand plan. Now that brings us back to this very famous image, Vitruvian Man, by Da Vinci. But Da Vinci didn't come up with a concept. He simply read it from a very ancient text, that being De Architectura, or the 10 books of architecture by Vitruvius. Book 3, chapter 1, I won't go through it all, but he talks about the symmetry of temples, and that this practice that the Romans and the Greeks were using is actually much older. They were just repeating what the ancients had done. And it talks about essentially the proportions of a man, measurement should be incorporated in the smaller and the lesser parts of a temple. So Da Vinci didn't do much of Da Vinci's work was just inherited from ancient writers. So that's in chapter 1, book 3, but in chapter 4 and 5, in book 5, I won't go for again, I won't read through it all, but book 5, chapter 4 of Harmony, book 5, chapter 5 of the vases used in the theatre. So they're literally describing the proportions of the way things should be done, and they should be done harmoniously in this obscure and difficult music science. So there's an old phrase, architecture is music frozen in time, or something along those lines. I'm paraphrasing slightly probably, but if you want to go further, that would be the source, because again he's talking about the fifth and the fourth in musical proportions, that it should be not just in the architecture itself, but even bronze vases that are used as sort of like bells inside theatres, etc. The harmonics that is famously in grand temples, so for instance Hagia Sophia, but also in cathedrals, an obscure and difficult music science, and it's because it's so out there, it is literally to be measured and written in ancient text and performed in architecture, but for some reason it's a bit of a out there subject. But ancient Roman weights and measures, you'll just see the same numbers. Now we'll be covering this more modern weights and measures, even when they're converted to the so-called metric which appeared later. You get harmonics in there all the time. When it comes to harmonics, Now, I'll be talking mainly looking towards historic or ancient times, but there are nice applications even in the modern age. Now, think of TV monitors. The old-fashioned TV was a 4 by 3. Monitors are now 16 by 9. These work nicely with the harmonic numbers as well. Now, we'll also look, so that's the size or the proportions of the screen, but look at even high definition, for instance. You have 1440, 576, 1080, 720. In the very harmonic in that sense as well. So these are features to consider. We'll go through. There's a lot of stuff to look at, across cultures, across time. But the question is, what is harmonics? Very, very difficult to give a concise answer. But what we can do is look at the applications, how it just appears again over and over. Not just people using the base 10 system, but for instance, you'll see it in Mayan and other cultures as well. So what is harmonics? We'll have a look through. This is a compilation of older videos. Have a good one, and hope you enjoyed. Hello, this video will be part of an ongoing series. I'll put the links in the description to the earlier parts. It's been a focus on harmonic numbers, what might be called, but especially how it applies to the quadrivium, so arithmetic, geometry, music, and astronomy. Also, weights and measures and Masonic tracing boards, which evolved from earlier craft guilds, which were engineers, masons, stonemasons, and the tools which they've been using since antiquity. I mean, Egyptian temples, for instance. Now, the pyramids, obviously not, because there's no real writings or carvings or anything like that to talk about those things. So, but when it comes to the great temples of Egypt, just roughly say the Middle Kingdom onward, places like Luxor, Abu Simbel, these types of temples, what we have is the compass and the square measuring rods. This has been used, these symbols have been used consistently throughout from that period up until to this day. And in the last 50 years, we've moved to electronics and to modern equipment. And so again, I've seen, people saying that, oh, well, masons use these type of tools now, diamond cut saws, these types of things, and therefore ancient people couldn't do it. However, before the introduction of diamond tip saws, pneumatic drills, these types of things, stonemasons have been at their art, at their craft for centuries before. And so I just have to say, if you hear this argument that diamond tip drills, all of that, it's absolute nonsense. It's bollocks, because stonework, elaborate, complicated stonework, existed well before this time, from centuries, consistently back through the centuries, through the millennia, back through time. And, well, okay, that's something else. Harmonic numbers, these symbols, so again, chisel, the trowel, the ruler, the compass and square, even the bell for signifying music, the hourglass, a measurement of time. These are all the square again, the plumb bob, the basic tools of measurement, and the craft of stonemasonry, of engineering, again, back consistently throughout time. Doric, Ionic, and Corinthian. Now, I've been talking about the long foot as well throughout this series, and how these particular numbers are at beautiful conversion points between multiple sets of measure, and Doric and Ionic are some of the most important ones, because Dorian and Ionian are also musical modes. But weights and measures, engineering, because, well, gods of knowledge, whether it was Thoth in Egypt, Hermes to the Greeks, Mercury to the Romans, and Nuar and Fuzi to the Chinese. You'll see again consistently the importance of gods and weights and measures. And so like Hermes is literally carrying a wand, and a wand literally translates to a measuring rod. And so again, we see the same themes of measure, which is essentially symbols of science. What is the scientific method based on? Measurement and observation. And, well, got weights and measures, knowledge, science, engineering. And so these are key symbols. So this is one of the reasons why you'll see this symbol in so many important places, but it's much more detailed than that. But also this is a good picture because it also incorporates some of the main themes that will be already been seen, but again will be repeated in this particular episode. So this is an Equinoctical Portable. It's a portable sundial. It's a measure, and it relies on a compass for you to, or the 360-degree protractor, or the compass as well. That's with the magnetic. Well, the compass gives you the direction, north, south, for instance. But so what we have is the compass and the clock, time and direction. Time tells us when we are. The compass tells us which direction we are headed. And even with the ruler, it tells us how far we are away. So some of the main questions which go to religion is, who am I? Where did I come from? Where am I going? The ruler tells you what, well, who, okay, a lot of these questions are actually answered by these exoteric instruments, but they complement and actually interact with the esoteric. And I think that but the esoteric and the exoteric are very bound together through Hermeticism. Now, Hermeticism is usually connected to the esoteric, but Hermeticism, Hermes, the god of weights and measures, Thoth, god of weights and measures. So these symbols is important. But so if I know the time and I know my direction and I know how far, not only does it tell me where I am and which direction I am headed and when I am, it also tells you when I will arrive. So some of these main, of all the religions, philosophies, who am I, what am I here for, where am I going, where did I come from, a lot of these questions are answered in here, and they're also literally navigation tools as well, mapping. But also the compass, and that's a geometry. Now, what does geometry mean? Now, people will think shapes. Well, that's okay. It's sort of true, but it literally translates to geo, as in the earth, and metry, as in measure, earth, measure. You measure the earth with geometry, and that's why such as the compass and the straight edge is so important to old-fashioned navigation and mapping, which in itself is a nice little coincidence because you're mapping things. It's like knowing where you are, where you've been, where you are going as well. So there are these deeper aspects to it as well. But the protractor, or the 360-degree compass, the ruler, weights, time, even pressure and temperature, we'll get into it more, but that's these are all very closely linked. So these are where we've already gone through, and now we're going to have a look at this column, 3 to the first. So we begin with the number 3, and the Trinity, for instance. Now, because 3 is a smaller number, I'll just leave it at that. There are so many other connections now. You could, well, we'll just leave that one for the moment. But it's also interesting that according to Bode's law, which is, it's banned to even mention Bode's law in some astronomical journals. Okay, well, that's another side topic. But so, well, beginning with geometry. So the first polygon, or the first shape we have, is a three-sided, the pyramid, or triangle, sorry, 3, and the golden rule of Bode's law is plus 4 over 10. 3 plus 4 over 10 is 0.7. Bode's law would say that Venus, so this is where Venus should be, and Venus is just outside of where Bode's law says it will be. That's an interesting point, because Venus is the only planet which rotates in the opposite direction to all the other planets. Something's happened to Venus in the past, and so this could, well, in my mind, I'm quite confident of it, that this explains the reason why Venus is the only is the planet which does not fit Bode's law exactly. But we'll get to more on Bode's law. So 3, and the next number is 6. And 6, well, 60 minutes per hour, 60 seconds per minute, reference to time, 60 minutes per degree, and 60 seconds per degree on the compass, for clock and the compass. 600,000 long chain, so the long foot once more describes the equatorial circumference of the Earth at 7,920 miles. The vesica itself with 60, but 6 is the most perfect of perfect numbers, and it's the only number which has this property: 1 plus 2 plus 3 equals 6, 1 times 2 times 3 equals 6, and also across dimensions have this same beauty connected to the number 6 is also, as an example there, how it goes through the dimensions, through the infinite dimensions. So again, the long foot being so important in regards to this is, also goes a lot to explain 33 feet, but we'll get into that in future. And so what we have is time and the compass, the clock and the compass. We also have references to astronomy, geometry, and arithmetic, the quadrivium. Now music will also come into this, but we'll see it more. So the next, so we had the equilateral or the triangle, 3. Now the next is, this is based on the Vesica, or sacred geometry as it's called. The next would be the 6-pointed star, 6 plus 4 divided by 10 equals 1. That's spot on, describing where Earth should be. Now 1 AU, an astronomical unit, is used by astronomers to, especially when they're talking about distances in the solar system. And it's just interesting that 1 AU is actually equal to 1 where Bode's law has predicted it. Now, ancient weights and measure systems, well, it's, again, they're all there. You'll even pay to, these other numbers I'll get to, or I've already gone into. And so it's built into ancient science. So 12, so the Kali Yuga, 432,000 years, that's 1200 divine years, as they say. 12, there are 12 constellations in the zodiac, which is a direct link to precession. 12 months in the calendar year, 12 being a lovely number across 3 dimensions. The Vesica, once more, 12 inches per foot. 12 just being so important, like the 12 apostles, 12 people in a jury, 12 people on a board, this type of thing. It's also, it's a beautiful number. Now we work in base 10, but there's still a movement, maybe it's not as big as it was a few decades ago, to go back to base 12 number system. So instead of counting 1 to 10, we would have counted 1 to 12. Is it the duodecimal system? Probably, yeah. Anyway, time, astronomy, and arithmetic, calendars, yeah. So you get the picture. Again, just repeated same themes. Now, Bode's law, 3, 6, and 12. So the 12-pointed star is next. 12 plus 4 divided by 10, 1.6. Again, describing where Mars should be. Again, 12. So New Jerusalem is 12,000 furlongs high, wide, and deep, according to the King James Version. Older versions will say stadia. And the Ark of Napishtim, which is the flood story, that's 120 cubits high, wide, and deep. And so the story of Noah is pretty much pilfered. It's a direct copy of the Ark of Utnapishtim from the Epic of Gilgamesh, also called the Preserver of Life, because the animals were saved and that type of stuff as well. Now, also he got a warning of people being sinful, just like Noah did. It's the same, including the releasing of a dove and a raven after the rain had ended, exactly like Noah. But that's something else. Weights, once more, especially the Greco-Grecian and Roman weights, reduced to the English troy weight. And we see how that comes on. Now, that's a big story in itself. But okay, 24 hours per day, long rods, describes the equatorial diameter of the Earth. Alpha to Omega, 24 letters, the Greek alphabet, 24 knuckles in finger counting. Again, 24 cross 1 times 2 times 3 times 4. Now, if I might as well go back and where have we got arithmetic? Okay. Oh, it's hard to tell there. 1, 2, 3, 4. Now, you'll also see this in people such as Kircher and others of, the importance of that. Okay, I shouldn't divert too much. And the Vesica, once again, geometry, time, the ruler, geometry, arithmetic, again. Now, interesting, Bode's law, at the time when it was brought up, the asteroid belt series was not known. It predicted not only that series would be there, it predicted where it would be. And that's one of the powers of Bode's law. Weights and measures, 24 again. And 48's the next one. So Satya Yuga, 1728, but that's 4,800 divine years, 48 days. Buddha sat under the Bodhi tree. Mary, Jesus, the mum of Jesus, was 48 years. Anyway, so you'll find it so often, but in weights and measures. So when they talk about the weight of gold and silver, they're not talking about the standard, pardon, food ounce, so 28.3 gram ounce. That some people, when you buy an ounce, when you buy organic plant material, let's just leave it at that. That's at 28.3 grams, but the troy ounce is 31.104 or 11035 anyway grams, but that's based on 480 grains. New Jerusalem, of course, but also in the rods. And the Arc of Napishtim, even Jupiter, so 48 pointed star, that's the next one, which we would get if you just keep that geometric system. And it's also, says where Jupiter is, pretty much it's spot on. And okay, also, well, no surprise there, ancient weights, Bode's law, and moment. Okay, so next on this column, 48, and we have 96. Again, weights and measures. Now you might even 9600 there for the the ancient Roman system, how it converts to the English troy, well, to grains especially. So we say English grains as well. So, well, 432, 144, 108, 72, 54. Same numbers we saw earlier episodes. Even again in, well, for instance, in printers, dots per inch, again 960 pixels, or DPI 96, and Saturn. So we have a 3, 6, 12, 24, 48, 96 pointed star emerging from the vesica. 96 plus 4 divided by 10 equals 10s, and spot on to where Saturn should be. It's also interesting in regards to the relationship between Saturn, time, and the Earth itself, as where Earth is 1 on the Bode scale, Saturn is 10. So there's some really nice connections there with Saturn, time, even speed, orbital speed of the Earth in relation to the polar diameter of Saturn. But next one is 192 on the Pythagorean tuning scale, music 192, and Uranus 192 plus 4 over 10, 19.6, again describing where Uranus should be. Now it's not as nicely placed in the middle, but Uranus is tilted. So just like Venus, there's evidence of some sort of impact, or something's happened in Uranus's path. It passed, and goes a nice way to explaining these little discrepancies that appear in Bode's law, because it only happens on these planets that have like Venus and anyway, Neptune as well. But so we have music and well, geometry, that's how we get this 192 pointed star, and that of course will also be a link to astronomy. Also, well, the weight scales, once again, same. All of these systems just come back onto one another. And 384. Now, well, one of the really cool things about 384 feet, and here I have Doric, Ionic, and Samian measure scales, and just again you'll see how these are 6, 12, 24, 48, 36, 108, 144, 432, 576, 1296, again 144. These are all, well, even 64, so we see there 64. These are all the harmonic numbers appearing, and at this particular measurement we have these archaic systems of measure just happen to come together with the so this column is what's considered the modern English foot. Now again, just like with the meter, absolute BS. This is not modern, even modern as I mean in the last 400 years. This is an ancient system, very, very ancient system. This is a World War II memorial in Washington, 384 feet. This is a Salamis stone. The stone itself, well, it's at a 2:3 ratio, and it also incorporates the Doric, the Ionic, the Samian, as well as here we see the modern English foot being represented in the Salamis stone. So the foot here, that's it there. That is the modern foot that we know, and this is from the Salamis stone at least 2,500 years ago. 348. Okay, we could finish off with Bode's, but you're starting. If you haven't got the point, well, anyway, it just continues on. systems of measuring spatial measure, as in varula, measurements of time, measurements of the compass, of the protractor, of direction, and again connecting with astronomy, connecting with the quadrivium, music, geometry, astronomy, and arithmetic. And so this is what we again consistently we see in ancient temples as well. So I just showed which is a modern temple, but even the most hardcore denialist doesn't, because it's just the written record in regards to, inverted commas, sacred geometry, esoteric, hermetic tradition in the design of Washington itself is so apparent that even the most die-hard denialist can't deny it. Or they won't. Anyone who tries to deny it, they don't know jack, because it's again, this is written. It's now Canberra in Australia is the same thing. Walter Burley Griffin was the architect. Even in the literature, when he spoke about it, did interviews, he talked about these type of features. Might not have used those exact words, but Nathan Richter was his professor when he studied in Chicago. Again, this is just another example of that. I'd welcome someone to try and have a go anyway, because I've had some people, will sort of come on and usually from a sock puppet account, 0 subs, no activity, and they come on and they try and drop something on there, and anyway, I'll sort them out quick enough because, well, do your best. Anyway, gods of knowledge, weights and measures. This is what's happening in this system. The Hermetic tradition goes back very, very long time, but even in just the last couple of centuries, the last 5 centuries, it describes our world. Hermeticism is about natural science, anything more than anything else. The modern sciences, as we know them now, emerge directly from these so-called pseudo-religious Hermetic principles. And those who will diminish this, they do a great disservice. Not just it's not their job to defend Hermeticism, but when they defend the scientific history and sort of try and separate it from this earlier period, either they're doing it as a dogma, and I choose that word as almost a religious dogma, that they choose to separate these because they don't want to accept the recorded history of these things. They have an agenda. They have something to protect, and it's very unscientific. It's non-research, and yeah, do your best, buddy. Do your best. Anyway, clock, the time, compass, the ruler, geometry, the quadrivium. All of these aspects are again quite ancient. Been written in. They still define our world today, and they were, in many ways, this system is much superior to ours because it incorporates several different fields under one umbrella. We now are so specialized that a geologist has no idea what's going on with a biologist, has no idea what's going on with any other field. This is not good. This is very bad, that what's happening, because when you look through a telescope, you see really far into the distance onto one spot on the horizon, but you don't see the bigger picture. Hermetics, this method, the 7 liberal arts, is about having a big picture version of natural sciences, of observation, and this is why it's superior in that way, but it's also superior when we're teaching the young. The state school system you go through, you come out, you don't really know anything, to be frank. You can read, you can do some basic arithmetic, but pardon me, if you've ever seen one of those vox pops when they ask people how long does it take how long does it take the Earth to orbit the sun? Literally that's a year, but people are, I don't. Even people who did fairly well at school, as soon as they come out of high school, for instance, or even university, ask them how big is the sun, how big is the moon, how big is the Earth, how big are they in relation to one another, about musical scales, and the education system has utterly failed, and we need to return to a more hermetic-like system. Now, I'm not doesn't have to be like this, but this is, well, much more holistic. I say holistic in as a whole, not using the kumbaya type of word that gets attached to it, but weights and measures, time, hermeticism, it's all beautifully, intricately linked. And again, this is the literature itself from going back centuries. They literally describe this in the literature. And so anyway, that's this column. Again, you could go into a lot more depth on each of these. Each time I do these, it's a short list, and it's quite cool method, quite cool system. I think, well, a superior system to what we have now. Okay, just be blunt, it's junk, what the method that we have now. Just in the time that I went through schooling in the 80s, and I started to see the beginnings. I was too young to realize it, but the beginnings of this new what we call now SJW system was already coming in back then. And it wasn't just about the whole SJW thing, but it was also about dumbing down. And everyone gets a prize. We don't want to upset people by giving them too hard of a question, so we're going to have some really easy questions. That way everyone gets it right, everyone feels good. Well, this is how we got to the state of affairs that we are now, and this needs to change. And so with that, anyway, the next got a couple more columns. For instance, this column here and this column here, but we're going to see the same thing happening. Again, you could extend it out, but in this series I'm just going to be focusing on this yellow, and then up to 3 to the 5th power. And again, links will be in the description to earlier episodes. It's geometry, it's arithmetic, it's astronomy, it's music. Why do we have a 24-hour day of 60 seconds each, of 60 minutes each minute of 60 seconds? Why is it a 12-inch per foot? Hello, this will be a continuation, unplanned series of videos, but looking at the harmonic numbers. So I'll put 2 earlier videos, I'll put the link in the description, but with a focus on the quadrivium. So what we have is arithmetic, geometry, music, and astronomy. The quadrivium is, well, the 4, then we had the trivium, the 3 together, 4 plus 3 is 7, the 7 liberal arts. So we'd have but these are the ones I like to focus on, because such as rhetoric, logic, and grammar, they're all part of the 7 liberal arts, but a little bit different, because especially arithmetic, geometry, music, and astronomy, so much connected to weights and measures, importantly ancients, which is a very important theme. So link in the description to the most recent upload. So that's where I went into 108, 216, 432, 864, etc., and how these connect to the quadrivium. But now we'll have a look at this column, beginning with 9 or 3 squared. And so 9, now Hashad numbers are 9. So for instance, 1 times 9 is 9, 2 times 9 is 18, 1 plus 8 is 9, 3 times 9 is 27, 2 plus 7 is 9. Recreational number theory, but any multiplication of 9 will give you the digital root, will come back to 9. So for instance, 11 times 99, 9 plus 9 is 18, 1 plus 8 equals 9. This is sort of what makes this particular number, as we use base 10, 9, so important. It's also 3 squared. But also historically, so we had the 9 gods in the Egyptian Ennead, 9 muses. Odin was on the tree for 9 days. But because it's such a small number, and by that I mean it's like, basically below 20, you'll find so many references to it that it could be, well, easily dismissed. But if you look at this harmonic series, so 9, and then so the next would be 18, 9 times 2, and then we start to, well, we'll see this pattern follow through. But what we have is, well, first astronomy, and so we have the moon measures, and one by the Ionic scale, and one by the long foot, also sometimes called the Persian foot. One long foot is 1.056 of modern feet. but also geometry. So, for instance, any triangle is 180 degrees. That's an equilateral. Doesn't matter what the triangle is. The angles will add together to 180. And we also see a reference to the vesica appearing as well. So this is especially the importance of time, the compass or the protractor of 360 degrees, a theme that will be repeated often. And also what we repeated throughout this column, and in the previous one where we had the sun and moon measures, and what we had was very often the long scale. So one long foot is 1.056 feet, and the ionic. So especially on this, we're going to see again the repetition of how important this long scale is, and further develop this idea, especially its connections to 33 and why 33 is so important. But also on this particular column here, we can also see the ionic scale of measures pop up again. So that's an ionic capital. If you probably go to any historic building in your city, your town, and good chance you'll see the ionic appear. But also in the previous episode where I went through 108, 216, etc., but this long foot or Persian foot, and how important this is for astronomical measures. And so 36, the next number, 3 plus 6 is 9, 4 times 9 is 36. So just an example of that Hashad numbers. So to begin with, very geometric. So whether it's the vesica, again, this constant theme, whether it's a circle or a square or a rectangle, any four-sided shape will have 360 degrees defining the inside. A reference to will intrigue, and so cosine 36 degrees is phi minus 1, phi over 2. Phi minus 1 equals 1 divided by phi. So this is a nice little thing in there as well. Of course, pentagram, angles, and even the icosahedron, 20 faces. Each face is one equilateral triangle. 20 times 180 is 3,600. So we see a geometry reference, and geometry, astronomy, arithmetic, and music. The quadrivium will be again constant. Will have already been, and we'll see more. In arithmetic, 36 is just a beautiful number. So it's a triangular number, but also how important it is across dimensions. So, for instance, you see there, and again, just one of these really pretty numbers and the way it works multiple dimensions. But you also, again, so just like 18, we're going to see the appearance of the long foot, again, to describe the moon. And so we have an astronomical reference. We have multiple references to time. So the Treta Yuga in the Yugas is a definition of time. 3,600 seconds per hour. And even in the Mayan count, 1 tun, 360 days. So we see references to time. We'll see references to weight. So, for instance, the old Grecian, Greco-Roman system of weights and how it just happens to convert to English grains. It's all very nice. 36, or harmonics from top to the middle to the end. It's the same again, but for instance, a jeweler, 36. But also by the compass. So, 360-degree compass or a protractor. Well, 360 degrees, and each degree itself is broken up into 3,600 minutes. So we see time for compass, or these same numbers convert even in the divine years in the Treta Yuga. And so a 360-degree compass, there are 21,600 minutes per 360 degrees. So it's 360 times 60. Multiply it by 60 again, you get 1,296,000 seconds in 360 degrees. And a yuga, what do we have? Again, 1,296,000 years. Nice connection there. And again, these are you just consistently see these in, measures of time, of weight, of distance, even temperature and pressure will appear more and more as we advance. So weight, time, and the compass, but also the ruler, again, the Persian foot, this long foot scale. So the next would be, so 9 times 2 is 18, times 2 is 36, the next is 72. And again, this now, just like the earlier column, 108, 216, we're getting to the very chunky, very meaningful part of it. But once again, geometry, so the pentagon, the pentagram, the vesica, the inside of a hexagon. So 120 degrees is the inside, or a hexagon, multiply that by 6, you get 720 degrees. there are 720 minutes on a 12-hour clock face. So if I was to multiply the outside of a hexagon, 240 by 6, I would get 1440, and there are 1440 minutes in 24 hours. But again, the tetrahedron, the golden number once again, cosine 72 degrees, phi over 2, geometry, and so again we're seeing geometry, so astronomy, geometry, arithmetic, music, and well, the quadrivium. So now, nice bit of astronomy going on. So we see sun and moon measures, and so 720 league, the mean diameter of the moon. Well, 1 league is 3 miles. That's how the imperial measures we use now, but earlier, well, throughout so many series, the importance of the Ionic and Doric scale of measure. Well, we see the sun and the moon coming together around the number 72 on the Ionic scale, but also around the number 72 we see the sun and the moon coming together around this Longfoot, this Persian scale, which again towards the end I'm going to do a repeat and a focus just on the long scale to show how important it is and how it connects to so many other important aspects. It is something of a conversion tool for these harmonic charts as well. Just measure, but truth will set you free. Now that's important as well because in precession, the cycle of a great year, the cycle of precession, typically we'll measure it on the spring equinox. You could choose some other point throughout the year, but what is important is, for instance, the spring equinox. If you watch the sun rise on the spring equinox, one of the 12 constellations of the zodiac will be behind the sun as the sun rises. So as it gets dark, there will be a constellation right on the horizon, and that will disappear as the sun rises. That's how we measure precession, and through his 25,920 year cycle. But 1 degree of precession is 72 years. So to do 1 degree of the precessional cycle, 72 years. Now that's cool because in biology, well, 72% of the human body is water, and at resting 72 beats per minute. That's 60 seconds per minute times 5 over 6, 72 is a nice reference there. But some biological connections as well, which is nice because 72 years is 1 lifetime, essentially, but it's interesting that time, 1 lifetime is 72 years or 1 degree of precession by the compass. So in 1 lifetime, basically 1 degree of precession is almost virtually, it's a bit arbitrary, but it's the minimum distance to measure precession just happens to sort of come together with a human lifetime and these other references to 72. Alan Green, I'll try to remember to put the link in the description, but he talks about, 1 foot plus 1 cubit plus 1 meter equals 6 feet, the connection between the cubit and the meter. I'll go on to say the importance of the meter in the 1 second pendulum, a measure of time, just happens to create an arc of 1 Egyptian royal cubit. So the cubit, this is the Egyptian royal cubit, E minus 1 feet. So 1 foot, E minus 1 feet is 1 cubit, and that's 1 meter. 72 inches. So again, measurements of time, these multiple ancient units of measure apparently separated and unconnected, always coming back together at especially the quadrivium, music, geometry, arithmetic, and astronomy. Also at 72, so room temperature, again, that will be a little, a fraction either way, but you'll see so often referred to as 70 degrees Fahrenheit. That's 295.37 Kelvin. Just shift a decimal point, 29.53. You'll get the Sun, Earth, and Moon synodic month there, but also in the Byzantine music, equal temperament. 72, but also ancient weight scales again. So 1 sextula, 72 grains, and 720p in screen resolution. Now these might have been a legacy from a more superstitious time to the recent pre-computer, pre-secular age. However, the modern computer age, electronic age, are in love with harmonic numbers. They use them all the time. Like you look at a screen resolution, file size, you're going to get these numbers again in the infinite sea of numbers. They could have chosen others, but they chose these because of their special properties. Now, for instance, 72 is divisible by 6, 36, 18, 12, 3, 4, 2, 8, and well, again, it has a lot of divisors. That's one of the reasons why these numbers, or even 60 minutes per hour, one of the reasons why these are such cool numbers to do these types of measures. But we also look in cycles of another reference to time. So the Mayan Katun, 7,200 days, and the Dwapara Yuga is broken into 72,000, 720,000, and 72,000, beginning, middle, and end period of this particular yuga. 72 is also linked in there, and so again, connection of time between apparently separate cultures. Set had 72 accomplices or disciples that conspired with him against Osiris in Egyptian legend, and Thoth won every 72nd day for the moon. So it's in ancient Egyptian legend. You'll find it in Far Eastern legend. Earlier episode talked about 108, but even 36 heavenly spirits and 72 earthly fiends. So both earlier mentioned 36, but also 72. And you will again, in the Shaolin, 36 movements in the small Luhan, and Big Luhan 72 movements once more, even 81, 27, 54. These are all 81, 27, 54. These are all harmonics consistently across time. And now let's look into one of the biggies, and amongst this chunky part is 144. Hello, this video will be a continuation. I'll put some links in the description to the earlier pieces. Well, quadrivium, so we have arithmetic, geometry, music, and astronomy. This is a ancient education system way of looking at the world. The quadrivium and a trivium, the 4 and the 3, together the 7 liberal arts, goes back at least 2,500 years BC. 500 BC, so 2,500 years old, at least in a recorded sense. But like it's so often the case, it goes back to this Greek period because we have such good records from that time. But these same elements we can trace them back through Babylon, the Indus, and to ancient Egypt. The earlier part, I'll put the link will be in the description. I went through this column and why these particular numbers, why they're so important across time, across cultures, across religions, but also in architecture, even in the electronics, screen resolution, radio frequencies. Very important, very beautiful numbers, and there's some very good reasons why they would use these particular numbers. But the previous episode to this, I went through this column, or began that column. So we had a look at 9, then 18. 9 times 2 is 18. Again, just the dimensional aspects of this is interesting. So you see 3 to the second, to the third, to the fourth, 2 to the first, to the second, to the third, to the fourth, etc. But okay, for instance, okay, we already went through 9. Okay, 9 is 3 squared, and we've been, okay, so 18. Same thing like geometry, arithmetic, music, astronomy, quadrivium, and Half and Nehemiah. Okay, so 36. So 9 is 3 squared, 36 is 6 squared. It's just another little, if you're interested in these little number things. Now, it's also, might be worth noting. So, okay, I've already been through 36, and again, astronomy, the compass, just the instruments of measurement, and the quadrivium, how lovely they're linked. So measurements of time, the compass is direction, but also of weight, and we've also had direction of length, space. The first spatial dimension or system of measurement. But okay, now for instance, 36 and 72. Now, if I add 72 plus 36, I get 108. If I add 144 plus 72, I get 216. So there's this. Now, if you were to follow that same rule, just how they sort of add up together as well. There's some. I did a video a while back on binomial theorem and different sort of way of looking at it. I think there's some very important, not just first, second, and third, but fourth dimensional is one of the important keys. Anyway, 72, we went through the same theme, 9 times 2 is 18, times 2 is 36, times 2 is 72. This, again, so many cultures. Now we'll have a look at the number 144, and well, on this particular column, probably the main one, at least the 144 is pretty cool, pretty important number. Now, to begin with, we have astronomy, and so this, both the sun and the moon, sun, earth, and moon, key forms. Now, even 1440 minutes per day, so 14, that's on the earth, so you could moon, earth, minutes per day, and sun, but sun and moon as the diameters. And it's also on this long foot, or the Persian foot, is also called. So one long foot is 1.056 of our feet. Divide that by 2, you get 0.528. Divide it 0.264, 0.132, 0.66, 0.33. So it's essentially the basic, or one of the key conversions to this would be 33. And so this is why other videos as well talked about 33 feet, 66 feet, how both ancient and modern just appears again. But we have astronomy as one of the four of the quadrivium, and also a measurement of time as well. So, but also more than that. So again, the Persian foot. Now, when I finish this, I want to go through and show how important the Persian foot is in this scale, and to converting to other ancient units, Doric, Ionic, the Mohenjo-Daro foot, and also connections to the cubit through the meter, and some other aspects. But so again, we have astronomy, we have time, that would also connect with the earth, but also weight. So the ancient Roman weight scales, again, which we've seen throughout the earlier numbers, appears again, it carries through to this period. So weight, but even screen resolution, so 1440p, and here in Australia, the way that they've set up the AM as well as the FM frequencies, all on this harmonic system. That's not an international thing. There are some, but Australia, very, very hermetic. Now, even so, the nonagon, you see like 40 degrees, the center angle, and well, in other, or the vesica, so the outside angle of that rhombus, 240, that's 14,400 minutes on the compass. The hexagon, again, so 240, the outside, that's emerges from the vesica. But in terms of geometry, it's got, well, more than this as well. So we see a geometric connection, but also in, say, the Fibonacci spiral. 144 is a Fibonacci number. So 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. 144 is the 12th Fibonacci number, and it's also 12 squared. So that's the interesting thing about these numbers, is how they all appear. Well, they have these cross references. Yeah, you bring it, so much comes in and forms the focal point. So often you'll be said that 864 is a sun number. I would say, no, 864 is a conversion number. Just like 144, 108, 216, it encompasses several pieces of knowledge and not just one aspect of it. But okay, even on the Euler's conjecture, it's interesting that in the fifth dimension, 144, this was one of the shortest math papers ever written as well. But again, just, you don't need to be fancy on this type of aspect. You just sort of prove anyway. But 144, 3 to the first plus 4 to the second plus 5 to the third. So 1440, exactly the same, plus 6 to the fourth. So we just add the fourth dimension. We continue the pattern, and we get 1440. I mentioned the binomial theorem, 4D matrix. Well, this is one of the important aspects. This will appear in that, but that's another earlier video. But geometry and the Fibonacci numbers, but also connections to arithmetic as well. So we have geometry and arithmetic. We've had astronomy, measurements of time, length, and these other aspects. So again, crossing the points. But okay, we also have the 5 Platonic solids, and so if you add up the faces of each one, you get the number of the degrees, and well, we'll see that one in a moment. But if you add them all together, 14,400, 144 once again. And geometry, but also, well, the octahedron is also this is the octahedron here, has 8 sides, 8 equilateral triangles, 8 times 180, gives us 1440. And again, this geometric reference as well. But in, for instance, the story of the flood from the Epic of Gilgamesh, when he describes the the ark that was built. You could say now whether it was a round boat as they built at the time, but the dimensions are clearly given. Now it might have been a round boat, might not have been a cube. Again, we're talking ancient legends and stories here, so we have to have a little bit of. I think there's some truth. Well, there is truth to it. I have no doubt of that. But when stories get passed on through time, little details can change. But anyway, this pattern, the area of each wall for 14,400 cubits squared, and even the total edge length 1440 cubits. Now, also in New Jerusalem, this very important part from Revelations. Now, in the earlier books of the Bible, there are also lots of connections, but the height of a wall was 144 cubits. That's 216 feet. And because it is being 12,000 by 12,000 by 12,000, it's going to have the same aspects here, just with more or less zeros, because that's 120 and New Jerusalem 12,000. But again, the same patterns. But 144 will also appear elsewhere, like for instance the 144,000. So 12 tribes, 12,000 each tribe, 144,000. You'll see other references to it. Very important number. But so for instance, the Mayan calendar, one Baktun, 144,000 days. The Satya Yuga, 144,000 years, the entry point. Then we have the middle piece, and then the exit part of that, 144. And even so 144 is 12 squared, 1728 is 12 cubed. So there's another thing worth considering. But these are references to time, and we have both in the early Hindu, Indian stories, but also the Mayan. And again, it's crossing cultures. Rosicrucians, 144 octaves and 144 elements. And now I could have done this with each of these numbers, but I'll show 144 as an example, because in architecture. Now, for instance, here we have St Andrew's Cathedral here in Sydney. Now there are other references to 144, but at 14 feet, that's 144 Cremona inch. And the length and the height of it as well will also incorporate 144. Why that's important is, well, great series building the great cathedrals. I know they're special, but they were talking about Amiens Cathedral and Beauvais. Now, Amiens, the height of the interior is 144 Roman feet, and the Beauvais Cathedral, the height is 144 royal feet. I'm calling that medieval royal foot, so it's not confused with others later. But this is an essential element in cathedral church design. They're both 144 feet in this case, but they've used a different system of measure. So this 144 Roman feet is slightly less than this. So these are not the same height, but they incorporate the same information, and this is one of the themes that they use. Once you understand what is the basic unit of measure that they're using in one of these cathedrals or ancient temples, all of this will emerge consistently, almost without exception. I really, offhand, I can't think of. You look at a major temple, you look at it, and you'll find it, and it's just repeated, measurable, testable. Parma Cathedral, it's one of these great cathedrals, 13th century, again 144 feet high. Now, this foot, 144 feet, as the 12-inch foot that we know, well, this predates that coming into existence. However, you'll find the foot appearing so often. Again, another story, but even in more modern of a basilica of is it Lichen? I'm not sure, part of my pronunciation, in Poland, the nave 144 feet. Now, even the yet nearly completed Basilica of the Sacred Family, Sagrada Familia in Spain, 560 feet the total, which will be 1440 Cremona hands on the scale when completed. It's also interesting to note that the groundbreaking and the completion schedule is 144 years, and it was consecrated on the 7th day of the 11th month, which happens a lot. But what is important, I think, is, so it's not just about measurement of length, but also measurements of time, for instance. And now I could put, okay, so 144 years the completion date. I should reference it, but the way when people think about all the people who are into city design, architecture, even in their own literature, the way they talk about these, it's also playing. What I'm trying to say is they play a long game at this. The guy who designed this and started construction knew full well he would never see it completed. That's the way it works with these big building projects. They're very rarely, if ever, completed within a lifetime. So as the saying goes, the old man who plants a tree knowing he'll never sit in its shade. This is one of the ways that they're thinking about this and working towards these things. Now I'll pause a moment. Okay, so Brasilia Cathedral by Oscar Nehemiah. He was the most important architect in regards to Brasilia, which is the South American version of Washington, D.C. He also designed the UN building, again, just full hermetic systems in there. But even so, these 16 columns, 90 tons each, so 1440 tons. So it's time, it's length, it's geometry, it's all these other aspects. It's not just one part. And where were we? Okay, so here we see. So with all these other numbers, okay, so 144 in measurement, but time, but also weight, how often it appears. Now, the next number will be 288, but on screen capture only gives me 15 minutes. Okay, so that'll be up in the next video. I'll follow on and just complete this little part of the series. Anyway, with that, hope you enjoyed. There'll be some more pieces to come. Cheers. Hello, this video will be a continuation. So in previous videos I went through all the harmonic numbers and how they are so important, especially to the quadrivium, but again, cross time, cross cultures, you'll find just consistently repeated, especially through Hermetics, Hermes, god of weights and measures, Thoth, god of weights and measures, and knowledge and writing. Basically, all the intellectual pursuits is very much connected with Thoth or Hermes. Similar in ancient China, so Nuwa and Fuzi, Ningishzida in Sumer, well, plenty of these types of gods. So we went through these numbers, and so for like links will be in the description. Went through 108, 216, 432. Previous episodes also like 9, 18, 36, 72, then one on 144 because it's a really charged number, that 144. But this one will be on the next one down, so 144 times 2, and we get 288, and that is one of my favorites, probably amongst these harmonics. 288 I think is my favorite, but arithmetic, geometry, music and astronomy, the quadrivium, and so 288. So we're just going to continue down this column, and 288. Now it's well, it's not strictly a Hashad number, but it is based on 9. So 2 plus 8 plus 8 equals 18. 1 plus 8 equals 9. So you know straight away it's divisible by 9, but because it's on this column, and well, all these after this column, all numbers are divisible by 9 on this harmonics chart. It's just because it's based on 3 squared, etc. But 288, why is it important? Well, there we see some of the connections. And so we begin, measuring temperature, the thermometer. So weights and measures is a system of measure as well. It connects to 273 and these other sun, earth, moon. It's astonishing, really. But so average temperature around 288 Kelvin. Now, because of, well, politics, anything to do with earth temperature is just, it's a hot potato, no pun intended. But so we have a measure of temperature at 288. Now also in geometry, so in a pentagon, 72 degrees at the central angle, but so therefore 288 on the outside. So get also a nice connection to the golden number as well. But also to time, so you get the Mayan calendar, the Picton, 2,880,000 days is one of those at 288, but also so it's a reference to time, measurement, also in music, D288 hertz. Now, That's sort of based on the ideal Pythagorean tuning from like 4-3-2, then 2 to the 2 over 3 or 3 over 2 is hermetic constant, the perfect fifth. But again, so nice connection with the measurement of music and also with astronomy. So we have the sun, and so this is a nice number because it brings together multiple units of measurement as well. So it's not just about getting the sun, but each time you'll see how, especially these very important 144, 108, 216, 432, etc. It's what we have is a conversion between multiple sets of ancient measures. So, for instance, the mean diameter of the sun in the cubits on the long scale, league. So 1 league is 3 miles. That's the mile we still use now. And it's also 288,000, etc. rods on the Ionic scale. So we have the long or the Persian, the so-called modern English, but that's nowhere. That's at least 1,500 years older than what the history will push to it, and there's physical evidence of that as well. It's just sometimes these, inverted commas, old wives' tales just get passed on, and because they get repeated enough, it carries on. But no, the foot that we use now is at least 500 BC, at least. Much older than that, actually, if you then take the evidence of all the old ancient temples around the world. But what we have is, so the Persian, the league or 3 miles, and the Ionic scale is in the Ionic column. Also, I've seen earlier videos, this very, in musical scales, the Ionian, the measure system of Ionic, and also the architectural school of the Ionic school of architecture, and also the 3 columns, Doric, Ionic, and Corinthian, most famously as depicted on Freemason tracing boards. But we have the sun, and at a harmonic point, like a unity point where multiple sets come together. So we have the ruler, the clock or time, measure of temperature, measure of music. We have geometry, and also in arithmetic, and this is probably why 288, so I like it so much. Now, for instance, is 4D, so for instance, 4, that's 2 squared, 9 is 3 squared, so, 1 dimension. This is 1, 2, 3, 4 in the second dimension, 1, 2, 3, 4, third, etc. Okay, so if we add them up from the top corner, top left to the bottom right, 288, if we multiply them from the bottom left to the top right, we get 288. Beautiful number across dimensions through into the 4th dimension. But again, very nice number. Now, okay, so, but how is this applied? Well, for instance, the Capitol building in Washington, 288 feet high. Now, the rotunda is 96 feet wide, which is 288 hand. But also Daniel Burnham, the Union Street Station in Washington, D.C. Daniel Burnham, very, very important, very influential architect, part of the City Beautiful movement. The height in the main hall there in the Union Street Station, post offices, train stations, ports are always symbolically through measures, and the symbols literally overflow with these powerful symbols from ancient times. And because it's a transport hub, a hub of commerce as well, so that's another reason. But okay, so we see 288 in hands, but back to the 288 feet high Capitol building. Well, the Mormon temple in DC there, or just outside of DC, anyway, 288 feet high, both of them. Now, why that's interesting, of special interest, because again, we go back to Siena in Italy, the cathedral, the hub of church power, and the Mangia Tower, the hub of secular power, both were made of equal height, 288 feet, to symbolize the equality between church and state authority. So I think that's what they've actually done here in Washington as well, and some other places too. But this is one of the importance. I'll do a huge list of, give me a capital, like a major capital building. Look at the center, you're going to find 288. It seems to be a number, especially connected with centers of power, political power, especially in the central axis, not just on some hokey corner in the building. I mean, through the main central axis of the building. And that, of course, being there through the dome. But again, lots of other examples, covered that in other videos. It's also nice that in the Sumerian scale, 200, or the Saxon foot, or the Indus Valley. So Mohenjo-Daro, the Sumerian foot, Mohenjo-Daro foot, and the Saxon foot, which was used up until the time of Elizabeth I. Well, 288 feet would be 261.81818181, and that is essentially phi squared, or phi plus 1. And actually not as defined by the Great Pyramid, that not without go. Okay, so forget about this. It's sort of true, okay, but if you take it too literally, that won't be correct. But still, you'll find this 2.61818118 again just repeats consistent. It's buried into a place, and it's all connected with Fibonacci numbers, especially 144, 55. Yeah, anyway, 377. Fibonacci's are one of the key points to all of this, and so this is one of the reasons why 288 is so important. Now, also might be worth, okay, so this, both the rotunda in the US Capitol building, the Union Street Station, 96 feet high, again, could list so many other important architects, cathedrals, monuments, major public buildings that have this measurement. But even in, so 1632, 64, 96, 128, 288, 384, 1152, these are all on the harmonic scale. So 1152, 384, 128, 64, etc. But on that same, so in the earlier episodes, we already went through, so numbers like 864, 3456, and the rest of these will appear, of course, on this harmonic chart. And the ones I haven't covered yet, I'm going to get to, because every single one of these is beautifully, lovely connected, especially through quadrivium, geometry, music, arithmetic, and astronomy, and again connected to multiple apparently separate cultures across the world who just all happen to choose weights and measure systems that just all come together at such harmonious, lovely points. And so that's one example of why 288 is important in architecture as well. You could go through all of these numbers, and again, just look for your Capitol building, your major war memorial, your major monuments, major cathedrals, major temples. Bang, you're going to get them all the time. So 288 times 2, 576. Again, so we see the sun, the Mayan calendar, 24 squared, 24 squared, and 12 squared is 144, 6 squared is 36 anyway. Even in screen resolution, so 576, and of course, once again, we find this long foot, the Persian foot, which, again, I have to get into that because it's just, I've been studying this particular measure for a while now, and it just recently, it just all clicked together, just amazing stuff. So we have time, astronomy, also through measurements, so the ruler, and again, electronic age, arithmetic. These numbers are just like lovely in that way. And so next would be 576 times 2 is 1152 times 2, 2304. And again, in the Mayan calendar, we see how these, the counts that they have, again, measurements of time. And, okay, I'll begin on this column, and I didn't talk about 27 or 54, and just to fill those in as well while we're here. So 3 cubed, that's 27, and here are some. Now 27. Now they're also, okay, again, 24 would emerge in here as well. Now because it depends on how you. Anyway, yep. So, but if you do have a look at 27 Hebrew letters in the Hebrew alphabet, that is correct. Now there's also more to it than that. However, it's worth mentioning. 27, just again, one of these cool numbers, bones in the human hand, the lunar mansions in Indian, that part of the world tradition, and of course 3 cubed. Now, just to fill these last ones in, so for instance, again, the pentagon, the pentagram, so the interior 108, 108. Anyway, add 5 of those together, and that's the sum of the interior angles of a pentagon. Now, it doesn't have to be perfect. Just like a triangle is always going to add up to 180 degrees, a square or a rectangle or any 4-sided shape will also always bring you to 360 degrees, and any 5-sided shape will bring you to 540. Okay, just to fill in those ones. And so we see 2 of those columns. And so we have well, we could go to the end, but so what I'll be doing is I'll be covering these, this 3, 81 or 3 to the 4th, and 3 to the 5th or 243. So I'll complete those in upcoming episodes. But yeah, it's all sun, earth and moon, weights and measures, proportions, architecture, ancient legends and stories, and martial arts, mysticism, just always keeps coming back anyway. So with that one, there's more to come, but just to explain, usually I'll do a video on a single building and sort of run through these fairly quickly, so I thought it'd just be worthwhile. Once you get this, it really is just a simple set of numbers. You only really need that column, and you need this column, and it's just 3 times 2, 4 times 9, 8 times 27. It's all there, and it's really cool stuff. Very, I don't know, again, I think this should be included in the education system, because, well, you can learn so many little about the relationships between things, again, different disciplines, music, astronomy, geometry, arithmetic. I'm not saying that it should be the education system. That's far beyond me to say that, but I think anyone who's been through the system recently in the last couple decades knows it's a stinker, and it's only getting worse, and something needs to be done about it, because the system's not just bad, like it's failing to educate people in not just facts, but also in critical thinking and thinking outside of a box. And well, yeah, it's going bad. It's not getting any better anyway. So with that, hope you enjoyed. There'll be more to come. I'll finish off the rest of these, at least the most important ones around this area here. Hey, going in this video, we'll have a look at harmonic numbers, but one particular column of those, and how much knowledge they contain, but also the connections through various civilizations, across time, across the world. I'll put a link in the description, because I've got a 108 video. That will be in the description. I'll go into that into a little bit more length and show, again, sacred architecture from the ancient through to the most modern of modern elements of our society, even including, well, the electronic age. It's still being used, very powerful, of course, but will upset some. But anyway, so we have this column here. So these are the harmonics, various, now 27, 54. I could go into them, but I'm going to start at 108. So we have this column: 108, 216, 432, 864. So 108, really powerful, very important number, again, cross time, cross cultures, across the world. More than a few sites. So if you do 108 number properties, 108 meaning, you'll find, again, how often it appears. It's not coincidence. It cannot be in the infinite sea of numbers, as they say. These apparently separate, independent cultures always come back to all the same weights and measures and the same very important symbolic numbers, and 108 is an important one, but also, well, just because of the nature of things. But for instance, 108, 1 plus 0 plus 8 equals 9. 216, 2 plus 1 plus 6 equals 9. 432, 4 plus 3 plus 2 equals 9. Now you'll find this continues. Now 864, 8 plus 6 plus 4 equals 18, but 18, 1 plus 8 equals 9. This is got to do with Hashad numbers and what's called recreational number theory. It's interesting point, but basically what it means: 108 divided by 9 equals 12. 216 divided by 9 equals 24. What happens is that any multiple of 9, so okay, now we'll just have a look at this column. So that's 9. Okay, so 9 times 2 is 18. 1 plus 8 equals 9. 36. 3 plus 6 equals 9, 72, 7 plus 2 equals 9. If you multiply any number by 9, the digits will then reduce back to 9. So that's why this happens, and there's more to it, but anyway, 108, it's basically a 9 number. Now, for instance, in Eastern tradition, like amongst others, Vishnu has 108 symbols attached to him. There are 108 chakras or pressure points. Sun salutations on the spring equinox in yoga, 108 sun salutations, and the japa mala, which are especially in the eastern, 108 beads. Very important number. It's built into. You'll find 108 in all the ancient Hindu Buddhist temples. That's one of these important features. But at japa mala. Okay, but okay, in Buddhism, so the Buddha, when he died, was said to have 108 auspicious symbols on each of his feet, 216 in total, but 108 on each foot. So it's now, for instance, in Wat Pho, again, you'll see the statue bears his feet, 108 symbols, but there are 108 offering bowls. This is another repeated feature. Japanese Buddhism, ring the bell 108 times for New Year. Buddha was once asked 108 questions and he made 108 statements. However, in Far East, in China, for instance, in Chinese literature, you're going to find 108, 108,000. These same will appear over and over, 108 stars of destiny. Interesting, in the Qin dynasty, Wan Li, very important character because he standardized architecture, many social aspects, but weights and measures. And also at that time, exact date I could never be sure of, but since quite a while ago in China, one must walk 10,800 li to reach wisdom. It's interesting that 576 meters, well, actually just a fraction under 576 meters, a couple mil from that, is 1,890 feet. That's 1 plus 8 plus 9 is 18. But the diameter of the moon is 1,890 royal miles. Shaolin, same thing. You see again these very important, based on 9, 27, 2 plus 7 is 9, 54, same thing, but 108 movements in total. But again, across the world, like weights and measures, so 108 grains, you'll find this in ancient weights and even in the 108 dactyloi. So this has to do with measures of field for tax assessment in the Byzantine Empire. But still with us to this day, a yardstick, even the word, a yardstick is a word you would use, to measure something. Is it truthful? Is it real? The yardstick. But 3 feet is 108 barleycorn. Stacks of timber, 108 cubic feet, so third dimension. But even pipes or butts of wine and beer, 108 gallons. Especially here in Australia, but even full screen, full HD, 1080, you'll see these same harmonic numbers defining screen. File size is just built into it. In Australia especially, FM was defined from 88 to 108 megahertz. You'll see it's slightly different in other regions, but the same thing happens in the AM frequencies because there's a 9 kilohertz separation, and so all the harmonic numbers will appear on your AM dial, here in Australia especially. But ancient legends, so we go back to the Epic of Gilgamesh and this, the flood story. Basically, it was the origin. So Noah's flood is a direct, exactly the same. It's including the dove and the raven being released. This will also connect to the Manu and the flood story in India, for instance. But throughout the descriptions of the Epic of Gilgamesh, from the size to the elements, how much pitch bitumen was put into the construction, even how much oil and was stored on, for instance. But again, the descriptions 108, 108, it's just repeated consistently. But even you'll find that, so New Jerusalem, which in itself, so New Jerusalem is either 12,000 stadia, older versions, King James Bible, it's 12,000 furlongs each edge length, and 120 cubits is the description of the Ark of Napishtim, also called the Preserver of Life. So again, because of this, basically it's built on 12s, you'll find that 108 or 108,000 are the edge length, but even when you convert to the Royal Babylonian system of weights and measures, the each individual edge is 108, and 7 zeros on the end. And again, it just appears again cross time, cross cultures, they're embedding this particular number. If it was sort of random and they weren't, and they were independently developed cultures, and it just wouldn't happen. It wouldn't happen, but it does. It can be weighed, it can be measured, it can be tested, it's repeated, not just in more solid weights and measures, but also in the symbolism, mythology, ritual, that type of thing as well. Very important. The quadrivium: arithmetic, geometry, music, and astronomy. So of the 7 liberal arts, the ancient system of education, the quadrivium most important, because these are also very much connected to Hermeticism, weights and measures, and how they harmonize. These harmonic numbers incorporate geometry, arithmetic, music, and astronomy. And for instance, in geometry, why is 108 so important? Well, for instance, we begin with a triangle, so 300 degrees. Well, there are 60 minutes per degree and 60 seconds per minute, so that's, again, 108, defining the outside of a triangle. Whether it's a square, whether it's a rectangle, any four-sided poly, you're going to find that if you add the outside angles together, a square would be 270 times 4, 1080, 108 again. So the vesica, all important vesica, because it's a four-sided, the rhombus on the inside, it's 4 sides, and so that's going to bring you to 1080 degrees again. Octagon, the inside angle, 8 of them, 135 times 8, same. Another feature with 1080, I'm not sure if I mentioned it already in this video, but for instance, screen resolutions, 1440, 1080, 576, etc. But the angles that, for instance, make up the octagon, defined by 1080 or 1080 degrees, that's the same angle that defines pyramids, all pyramids, not just a Great Pyramid as we see here, because a pyramid has 4 sides, each side is a triangle, and it has the base, which is a square. 4 triangles, all triangle angles add up to 180, so together the face angles of the pyramid are 720 plus 360 degrees for the square base, which gives you 1080 as well. So again, just another how these numbers are just wonderful on their own, has a way to remember things, meaning, depth, origin, where and why. These are very tough questions, but at the very least, if it's just a system to incorporate, and memorize knowledge in different levels of one number, gives you so many aspects to consider. And 1080, 108's, apart from 273 or 27.3, 108 is, I think, it's my favorite number. The pentagon and pentagram, so 108 degrees, you'll find that through, again, one of the key defining angles of the pentagon and the pentagram is 108, but also has the pentagon and pentagram relates to phi, or the golden number, the divine proportion. Even in trig, you'll see how this connects to phi, the golden number. Again, just, I know even the other angles, so for instance 36 and 72, same thing happens again with the golden number coming to these things, and these are the numbers, not just harmonic numbers, because for instance, 36, 3 plus 6 is 9. These are all on that harmonic chart, 36, 72, 7 plus 2 is 9. And this has to do with a 360 degree compass, but even, 30 degrees, and the pendulum from the 1 second, 1 meter long pendulum, how it connects to the Egyptian royal cubit, and pi over 6 radian, and again, just beautiful, 86,400 seconds per day. We'll come to that. So 30 degrees, that's 108,000 seconds on the compass. So across geometry, even time, weights and measures, very, very hermetic, 108. In arithmetic, again, so 108, you see, lovely number there, same thing happens again, Harshad, numbers, recreational number theory. Beautiful number again in cross dimensions. And in astronomy, for instance, if I multiply the diameter of the moon times 108, I get essentially spot on, very, very close to the average distance from the moon to the Earth. 108 of the moon's diameter is the distance Earth to moon. But in this long foot, or otherwise sometimes called the Persian foot, the diameter of the moon itself is 108 once again. So carries on. So interesting that the atomic weight of silver, 108 mole, and by the light of the silvery moon. So 108 is not just a moon number, actually connects many things, but it's a convenient way to think of it as silver or the moon. 108 solar system carries on, but for instance, so we already showed 108 times the diameter of a moon is the distance from the moon to the Earth. Very, very close to being spot on to the average, because of elliptical orbits these things always change a bit. But if I also multiply the diameter of the Earth times 108, I'm essentially getting above 99.9% probably, so, but very, very, very close to it. Diameter of the Earth times 108 equals the diameter of the Sun. And if I multiply the diameter of the Sun times 108, I get the distance from the Sun to the Earth. At its top speed, the orbital speed of the Earth, 108,000 kilometers per hour, which is the polar diameter of Saturn, again above 99.95, I think, percent. But even because it's a gas planet, it's not, it's not clear cut where the edge is, and so it's essentially spot on. You could think of it that way. Not quite, so I'll put an asterisk there, but it's 10,800 days for Saturn to orbit, like one Saturn year, 10,800 days, within a very small margin. There are other things need to be taken into account, so I'll put the asterisk on that one. However, if just like the Earth, if I multiply the diameter of the Sun times 1,080, I get the distance from the Sun to Saturn. So again, weights and measures, proportions, it's all linking up together. In music, again, you'll see 108 Pythagorean tuning, the pentatonic tuning, 108A. So that's 108. 216, well, there are 21,600 minutes in a 360-degree compass. Of course, by definition, the circumference of the Earth is 21,600 nautical miles. The diameter of the Moon, 2,160 miles. Each age in precession, on average, is 2,160 years. The walls of New Jerusalem, talked about that earlier, how important that is. Well, the walls themselves are 216 feet high. A cube, one of the Platonic solids, 2,160 degrees. And it also appears in the vesica. Now, I should have been, well, it's also in the vesica itself, 108, or a few other aspects of that. But 216, these harmonics. And so 108 times 2, 216, 216 times 2, we get 432. What's the diameter of the Sun in the long scale? The Arkavut Napishtim and New Jerusalem also incorporating this number multiple times. Ancient systems, for instance, Roman, 1 ounce, 432 grain. A in the standard tuning, Pythagorean tuning, 432. And the Yugas, so the Kali Yuga, 43,200 years, and even the lifespan of a Manu, 432,0000. Okay, so once again we've gone through 108, 216, 432, the Sun, weights, the New Jerusalem, the preserver of life as the Arkavut Napishtim, the flood, and we also see 432 being represented there in the lifespan of a Manu, which was again the Indian flood legend, and the Yugas for 432,000. Now the radius of the Sun is 43,200. We'll get to that. Tuning systems, the Pythagorean tuning systems and the Vesica. So we have the same themes with Sun and Moon, the New Jerusalem, the flood legends, the Yugas, systems of weights and measure, including music, of course, and, well, the Vesica, always the Vesica, and how this just happens to correspond to ancient units of measure, just happen to convert at these very beautiful numbers where we get the same repeated theme. So 432, now we double that once again, and we get 864. And 864, well, once more, the Yugas, the Vapara Yuga, 864,000 years. Once more, the Vesica, 240 degrees. The outside angle of a rhombus is 864,000 seconds. Again, 864,000. But it extends. Okay, so the Sun, the Earth, the Moon, Jupiter, and Saturn. And so, well, 864,000 miles is the diameter of the Sun, above 99.9%, but also because of the different techniques on how you define the outside of the Sun, and I should say well, essentially the mean diameter, so the average polar equatorial diameter, or I've labeled equatorial, but really it should be the mean diameter, 86,400 miles. And well, Jupiter again, so the mean diameter of Jupiter, again, that should be over there as well, but 86,400 miles, 1/10 of the Sun, but there are 86,400 seconds per day. 24 hours breaks down to 86,400 seconds per day, which brings us back to the 1 meter pendulum being 1 second that connects to the Egyptian cubit. We'll come to that in a moment. So that's the size and time. But we also have orbital speed, so the orbital speed of the Moon, the average, but so we have a minimum and a maximum, and so the Moon will travel through that point, 86,400 kilometers a day. And well, back to 864,000. Well, the orbital speed of Saturn, 864,000 kilometers per day. So we see these themes, these repetitions, but while we're on 86,400 seconds per day. Let's pause a moment. Okay, so back to the meter pendulum. So it's 86,400 seconds per day. That section of arc is pi over 6 meters. Effectively, we've been splitting hairs, 1 Egyptian royal cubit, and that 30-degree angle. The pyramid itself is, well, Heliopolis is 30 degrees north of the equator, so again, 108. But this 86,400 seconds per day, and well, if we look at the pyramid, so it's a three-dimensional object. If we stand at the northeast corner, especially because that's the most, it would apply across the pyramid, but this is the most accurate corner to describe this. And so we have, it's a pyramid, not a triangle and a square, and so standing at the corner, the most you'll ever see of the pyramid is 2 sides, and we'll see the height. And well, so including the sockets, the maximum visible base of the pyramid is the rotational speed of the Earth per second, and therefore if we multiply that by 86,400, we get the equatorial circumference of the Earth equal to, or essentially equal to, the best modern measurements of the size of the Earth. And the equatorial circumference of the Earth, I mentioned earlier, is 21,600 nautical miles by definition. But again, these 108, 216, 432, 864 coming back. So, but that's the equatorial circumference. And so now if you measure the height of a Great Pyramid, including the paving stones, the socle, and multiply that by 86,400 seconds per day, we get the polar diameter of the Earth. So we're describing the whole Earth, so the circumference and the height. And that's so 86,400 seconds per day, the meter, the pendulum, the second, all coming together nicely. Now that will blend very, very nicely with these other aspects of it. And so back to, so this is why these numbers are so cool, so important. So it's Sun, Earth, and Moon, but we're also going to get quite a bit of other planetary information. So the diameter and the speeds of Jupiter and Saturn. We already saw how Saturn connects to 108 as well, and as the Sun, the Moon, and the Earth does too. So that's 108, 216, 432, 864. Now if we multiply by 2 again, staying on this column on the harmonic numbers, 1728. Well, New Jerusalem and the Ark of Napishtim, or Preserver of Life, once again, 1728, describing its cubic, so its three-dimensional volume is 1728. The Satya Yuga, 1728, 1,728,000 years. 12 cube, but okay, but again, the Sun and the Moon. So we're getting again these descriptions. So the Temple of Man, especially connected with flood, the Ark of Utnapishtim and the Yugas, the cycles of destruction of the Manu, current Manu as it described, was the survivor of the flood, just the same way that Utnapishtim, the ancestor of Gilgamesh, survived the flood with the Ark. Just like the Manu, he had 7 sages to repopulate the earth. He also carried 7 vessels of seed to renew the crops as well. And again, in the long scale and in chains. Now, one chain is 66 feet or 4 poles / perch. Did a recent video on how that connects to also, well, again, just extraordinary set of you want to call it coincidence, good on you, but yeah, it just carries through. It's crossing time, crossing cultures. It's being repeated over and over again. Systems of measurement: sun, earth, moon, the planets, the temple of man as well, New Jerusalem, or Napishtim, the flood legends, always coming back to the same themes. And so 1728. And so next one would be 3, 4, 5, 6, 3,456. Well, there we get a nice, well, we're going to get back to rods or poles or perch, which is 16.5 feet. So one rod is 33 feet divided by 2. The chains, we get the radius of the sun. We get, on rods, we get the radius of the moon. And we also get the polar radius of the earth, Egyptian royal miles, or the royal mile, which is an 8:7 ratio, which has, again, in music theory, has lovely connections to that as well. It always, geometry, arithmetic, astronomy, and music consistently coming back. These ancient systems of measure were designed with some sophistication, but genius is the only way to describe it, because even when you break down the rod or you break down the chain or the royal mile, you will always come back to these very specific sets of numbers which will describe sun, earth, moon, stars, speed, size, proportions in architecture, and musical aspects, but they're lovely numbers in arithmetic. And so that's one aspect. 3, 4, 5, 6. Now we multiply that by 2 again, and we get 6,912. Well, sun, earth, and moon described here. And I think this is an interesting point, because when you do for instance, when you do this 108, 216, 432, you can get sun, earth, and moon numbers, but it's more, so the sun and the moon are described in their diameter, equatorial diameter, the best way. It's actually mean diameter, but just for just illustrative purposes. But when it gets to the earth measures, we now have to look at the polar diameter, not across. And that's interesting because, well, as a person standing on the earth, how do you relate to the sun and the moon? You relate to them through the horizon, across, horizontally, as when we have the earth, we're standing on the earth, and it goes, well, nicely described, I think, by the polar diameter. So what we have is these harmonic numbers, and each row, each column is full of profound information. So I've just focused on this column: 27, 54, 108, 216, 432, and well, just do a quick review. You'll see like weights and measures, especially connected to the temple of man or the holy city, and the legends of the flood of Napishtim, or the Manu in India, the quadrivium being the basics of these. And so geometry, arithmetic, music, and astronomy, time, proportion, it really is all here. And with this very simple system, you get a really, you learn a handful of numbers, and you've memorized so much important information in a very simple way. And it's just still staggering to me. Like the school system that I went through, we come out the end of it not really knowing anything. Everything we were taught was in this fanatical decimalization, where a number wasn't sciencey if it was a whole number. If you wanted to do a measurement, you had to have a couple of digits, a dot, and then a long string of decimal points, and that was sciencey. But anything which was, well, why are some educated in this particular, why is the 7 liberal arts, especially the quadrivium, taught in certain schools, but it's not taught to the servile classes, such as myself, and I'm assuming most of you as well? Well, it's part of the dumbing down of the system, and it's also the gatekeepers who, again, you show them a clean number like this, and it's it's not sciencey, like it's pseudo, it's fringe or whatever. But if I was to show them a random decimal number and say, okay, that's the diameter of a sun, oh yeah, that seems all right. Not that they know that it is, but just because it looks sciencey, because it's this string of numbers that's hard to memorize. But with these numbers, you're really getting a beautiful system. It's a connected, it's an integrated system, and our ancestors who designed the 12-inch foot and the 360-degree compass, 12 hours per day. This goes back millennia. Now, the exact date on when certain things emerged might be argued, but even at the very youngest, it's 1,000 years old. However, through studying ancient systems of weights and measure and ignoring the pseudo science that I was taught as official science, such as the origin of a foot, the origin of time, that's the fringe. That's not even the fringe stuff. It's just it's based. It's a dogma. It's almost religious. As where this to show this, so many would accuse you of engaging in some sort of religious pseudoscience, but I really don't. It's a beautiful system, and one of the criticism might be, well, it's only 99.9% accurate. Well, so is everything else, So when the official measurements, if you read the fine print, they're going to have margins of error and all these other aspects in it. Very often when people talk about measure, they don't realize the difficult issues in measurement. So, for instance, if I want to measure a coastline, I could look that up and say, the coastline of this island is 2,000 miles. But that's based on a certain type of measurement. Now, if I was to measure it exactly the same way, but instead of using a 1 meter ruler, I was to use a 1 centimeter ruler, that ruler would now catch more of the little curves in the coastline. And now all of a sudden the 2,000-mile coastline of this island is now 10 times larger because I'm using a more accurate measuring system. So we have two completely separate, two different numbers, hugely different, yet they're both true because they've both been measured. And well, that's an important point, I think. So if someone criticizes, well, they're rounding off or whatever, well, they're also rounding off because they're not talking about the issues that go with measurement and the complexities. And so often, if you do a Google search and you go to the Wikipedia, they'll give you a number, and they'll think, it's on the internet, and so therefore it must be true. But then if you look deeper, you'll see how there is, conflicting information because, for instance, how do I measure the sun? The sun is this big gas bubble with ripple edges. It's not like a clean surface where I can say, here's the surface and there's the atmosphere. It's more complex, and so they have to use approximations to find out, how do we define margin? So there's margins of error, but there's also what could be called margins of definition. This is how I define what the surface of the sun is. Anyway, 864, 108, 432, 1728. It's cross time, cross cultures, built into the solar system, it would seem, in old legends and myths. Anyway, with that, hope you enjoyed and have a good one. Hello, this will be part of this recent uploads ongoing series looking at the often referred to as the harmonic numbers, and now my computer's going a little bit slow, but the links will be in a description to the earlier parts, and I'll go through some more of the important columns. So this is the number chart here, just based on 3 to the first, 3 to the second, 3 to the third, 2 to the first, 2 to the second, etc. And we've gone through links in the description. Previous episodes gone through these two columns, and now we'll have a look at this column, 3 to the fourth. But firstly, consistent themes that go throughout these numbers, which can be applied to both ancient and modern esoteric architecture. The quadrivium, for instance. So we have arithmetic, geometry, music, and astronomy. Now the quadrivium are 4 of the 7 liberal arts. So we have grammar, rhetoric, and dialectica. So this is the trivium, what's often referred as the 3 lesser of the 7 liberal arts. These 3, we also have music, arithmetic, geometry, and astronomy. So this is depiction, you'll see very old system of doing these things. Now we're also not Socrates and Plato being there in the middle. Interesting, these outside of these diagram illustrations, you also find it carved into places like Chartres Cathedral, over 800 years old. But of course, it does go back to roughly 500 BC. That's in the written records, but that, for instance, the Parthenon contains the same type of information, numbers, measurements, systems, to be found in much earlier Babylonian, Persian, in India, in Egypt, suggesting that the quadrivium is and the seven liberal arts are much older than what might usually be the credit, the time given to them anyway. So also worth, because previous episodes I went through the differences in columns, but for instance this is a Mason tracing board, a modern one. Compass, we have all sorts of devices for measurement systems, even the bell connecting to music, and the compass, rulers, the square, plumb, these are all, for a stonemason engineer, still to this day, but of course going back to modern times, this was how they were doing this from the beginning of this recent electronics in the 19th, 18th, 17th, 16th century, going way back. They've been using the same tools, and you can even find those depictions in ancient temples as well. Same symbols, part of this. Well, it's been passed on, but important feature, for instance, previous column Ionic was in the Ionic column, and we have the Doric column. The previous episode we saw the long foot come up again, but how the Ionic happened to appear on that particular set of numbers. But now we're going to see that the Doric column is the one which will be the most important. But also worth considering Hermeticism. So Hermes, the Greek, Mercury in Rome, and Thoth, they have similar themes. A bird hybrid, wings on his feet. The Kundalini, the snakes are about the rod, and gods of knowledge, gods of weights and measure, and commerce as well. And this will also apply to navigation, geometry, especially is at the core of navigation. But for instance, Darius with a measuring rod, Thoth with a measuring rod. This crosses Nuwa and Fuzi. These are the Chinese creator gods, and they, you see these geometry, the geometry, the compass and square, the twin snakes, just like in we see, for instance, two snakes around the rod there. Even in Hermes, and even on Thoth, he's carrying two rods, but again, these twin snakes. Same themes, and it goes beyond just the gods of weights and measure, especially this bird hybrid theme. Just one, clearly they're in the coincidence and chance can only go so far to explain how this connects so many cultures, again, cross time, apparently, allegedly independent cultures, but same thing, Thoth, Nuwa, Fuzi, Ningish Zeta in Sumeria. Again, the twin snakes, the measuring rod, a very important feature of these civilizations. Is one of the defining points of a civilization is language, but also a standard units of weights and measure. Even Sumerian, Inanna's descent into the underworld, the first thing she had to let go of was the measuring rod of lapis lazuli. Hammurabi, he's carrying this rod with the curl. That's literally, I forget the actual name of it, but that's a system of measure. And you'll see this, so the kings and queens still carry the scepter and orb, weights and measure. That only, to have that authority, that power to define what is the standard weights and measures, which would apply to taxation, land, area of land, all this, everything essentially important in a civilization, in the management of it, comes back to standard weights and measures and these types of things. Australian ibis, virtually identical to the sacred white ibis of Egypt, which was Thoth, some tough, different pronunciations. I prefer Thoth. And okay, freezing up. Okay, and we also have the caduceus, sometimes called the kundalini as well, the twin snakes, symbol of Hermes, god of weights and measures. So previous episodes we went through these columns. Now we'll have a look at this column, beginning with 3 to the 4th, or 81. 81, now 81 3 to the 4th, that's why I got this. This is a tesseract as drawn by Claude Bragdon. But the ratio of mass, basically the weight of Earth to the Moon, is a ratio of 81 to 1. Now, is it John Martineau? I think he wrote the little book of coincidence, but he was talking. Well, now I've got an asterisk here, so I haven't checked this, and I probably really should have. It's been so. But anyway, the ratio of mass Earth to Moon, 81 to 1. But because the Moon is orbiting the Earth as the Earth orbits the Sun, the Moon has the speed of the Earth plus the speed of its orbit around, well, its speed through space. And according to John Martineau, again, asterisk, it's a ratio of 1 to 81. So the Moon moves 81 times faster through space to the Earth. But asterisk could be something, not something that I've checked again. I should have. But astronomy connections, once more, this quadrivium, but also a reflection of weights and measures and weight. So 81. Now we go to 162. That's 81 times 2. That's a very simple pattern. And okay, 162. And to begin with, I mentioned already the Doric scale, and Dorian is another word for it, and Dorian is also a musical mode as well. But we have the mean diameter of the Moon, Sun, Earth, and Moon. Now, I'll go back and have a look at that tracing board again, because that's an important theme, which is a standard theme throughout this whole, the Moon and the Sun. Now we have the terrestrial sphere and the terrestrial and the celestial. So Sun, Earth, and Moon and stars. The Sun and the Moon, the Earth and the zodiac, all the stars. So that's just a point, because these particular astronomical measurements of both size and all these other aspects as well, especially connect Sun, Earth, Moon, and stars. So 162, we get an eye at the Moon and the Doric scale, astronomy. The Doric, the Doric column, basically, there's slight variations, but it's the column which has this very simple capital. Sometimes it's fluted, sometimes it's whole like this, but that's a Doric column. And there's another tracing board. That's an example. You always see Doric, Corinthian, and Ionic columns. Sun and Moon, again, as standard themes as well. Now 324. Okay, so pentagram, 36 degrees is the point, the angle, and so 324 defines the outside. Pythagorean tuning, 324. And now the long foot, again, which has been this consistent, a feature which joins all these together. It's lots and lots of information in regards to this in the future. Very, very important. But also, so again, 324 and 5 zeros hands on that scale brings us the Moon. So we have astronomy, music, and geometry in these themes as well. And we'll could say arithmetic, because we're using numbers, but it's a little bit different. Now 648, the Sun and the Moon again, the Doric scale once more, precession, the precession of the equinox, or the great year as well. So between each, so 1 year is 25,920 years. 1 season is 6,480. It's also interesting apothecary's weights. Apothecary, a pharmacist, old-fashioned chemist. Now, just happens to, well, there's a few other connections there, but 648 grams. The metric system is very, very old, and well, it's again, okay, something metric is old, both in weights and in measure, as in the meter. Much, much older than what the official history says. Even the official, most of the mainstream will even say it had to do with measuring the size of the Earth. However, centuries before that, Marin Mersenne, other people have been writing on it, using it to measure the second. And so, yeah, the official story of a meter at least it's centuries off. Usually, very few people include the earlier information, but at the very least it's centuries off. And so in fact, once we can say it's earlier, we can just throw away the official standard version was done by measuring the size of the Earth. No, it was actually in existence earlier to that. It's got to do with measuring the second. But so we have, again, okay, the Doric column. So we see Doric, Sun and Moon. And geometry, as in the dodecahedron, the angles which define the dodecahedron, same as in the years in the Platonic season. We have weight and astronomy connections there. So weights and measures, quadrivium, 1296. We have same thing again, long foot, and the long foot for Sun and Moon, 1,296,000 seconds, a 360-degree compass. Each 360 degrees is divided into each degrees of 60 minutes. Each minute is of 60 seconds. So there are 1,296 seconds in the compass, 1,296 years in the Treta Yuga. Some descriptions are saying of Plato's number. Again, just we add a 0 to the end. And it's also 6 to the 4th. 6 times 6 times 6 times 6, and that's why I got the Tractus there. Once again, even in Australia, the way they've set up the AM and FM frequencies, they've done it spot on. Very, very hermetic. And so once more, we have astronomy, we have the compass, we have weight, measurements of time, and well, again, same sort of themes continuing again. Next one, 2592. This is important in precession. I already mentioned, so there are 25,920 years in the Great Year. And on the Doric scale, rods, what do we have? The Sun, 2592. Sun, Earth, Moon, and stars, weights, and measure systems. I'm using a Mason tracing board here, but I could have gone one before the Masonic lodges as we understand them were created, because it goes back consistently throughout all of time. I'm just this was not created. They're passing on ancient systems. Ancient knowledge has been passed on through these types of symbolic representations, most famous for Masons. And 5184, that's the next. We just double 2592. Well, on the long scale again, we get the Sun, and even, again, ancient Greco-Roman systems of weights and measure, 5184 grains. Astronomy, weight, and again this Persian foot. So mentioning 5184, well, as I think these are like mnemonics, they're great ways to remember things, these particular sets of numbers. Now, for instance, the slope angle of a Great Pyramid, 5184, 51.84 degrees. Again, well, the Mohenjo-Daro foot is equal to the Royal Babylonian foot, which is equal to the Saxon foot, and again, so we have a moon reference there as well. So another nice connection to astronomy. So that's those three columns there. They all connect. I'll when I complete the major portion of this, I'll do a series of connections as well, just to show Doric, Ionic, the long foot, how these ancient systems of measure are beautifully and intricately connected around the quadrivium and systems of weights and measure, ancient ones which still carry through with us to this day. The ancients still define our world. And okay, nearly 15 minutes. Okay, so with that, hope you enjoyed. Links in the description, the previous episodes, and more to come. Cheers. Hello, this video will be one more in the ongoing series focused on what's often termed as harmonic numbers, especially how arithmetic, geometry, music, and astronomy, the quadrivium of the seven liberal arts, and the trivium is separate from the quadrivium. One of the most important aspects, I think, is the quadrivium deals with measurables, with tangibles, for instance. So astronomy, music, arithmetic, geometry, these are all things of, you can count, you can measure, you can observe, you can weigh, as where the trivium deals more with the grey areas of existence. So for instance, the trivium, if you study law, grammar, logic, rhetoric, important aspects of the law. Now that's dealing with grey areas of society, and again, the law, it's about still they use to weigh the evidence, for instance. But the trivium is more, yeah, to deal with the grey areas, but the quadrivium is more solid area, and that's why I think it's interesting and important geometry, compass and square. So these are the numbers we've gone through before. Links will be in the description to the early ones, but now we go to the next column, and for 86, and there we have in Pythagorean tuning B, and I won't go through all because it's really, this part where I've covered is the really chunky area. Now there is everything throughout here has some interesting connections, but this piece is, you know, the chunkiest, the most heaviest in cool info. So for instance, 3,888. You know, if you just if you search these numbers, there's a lot more to them than these. I'm just sort of with the cards I've got prepared, and it's a short list really. Lots of other interesting aspects in regards to each one of these numbers, but 388, 3,888. You know, we have a reference to the size of the moon, and 31,104. So the year of the Brahma, we see how this number now throughout Buddhist and Hindu arithmetic and sacred number. This is where they're all on this scale. So it's really also in regards to sacred number, it's all in here. But on that same, so 31104. Already earlier mentioned the 280 grams in the troy ounce, which is how we measure precious metals, gold and silver. If you see the price quoted for that, well, that's 31.104 grams. I should put a little asterisk. Sometimes you'll see 31.1035, but the value of a grain changed ever so slightly in the not too distant past. But even if you do 31.104 grams, you'll find that that's often quoted. But if you look a little bit deep, you'll see 31.1035. But just a heads up there on that. But well, if you can measure to is that 1/10,000? Yeah, well, 5/10,000ths of a gram, you're doing really well. If you were buying in massive quantities, that would of course be an important. You'd want to include that. But if you quoted 31.104 grams, if you can get that on any scale, well, you know, you're doing bloody fantastic in terms of calibrating your equipment. So what we have, again, the same themes: weight, measurements of time, astronomy, and music. So these same themes. Weights and measures, hermeticism, and the quadrivium, for instance, astronomy and music. And these all tie in together. So it's also at 486 for B, so that's the previous numbers, and we see the music scale. Now that's 192 is to 288, that's a 2 to 3 ratio. And then 288 to 432 is a 2 to 3 ratio. 2 to 3, just like in the Vesica, 2 to 3, and that's the perfect fifth. And 234 is 3 to 2, and 324 to 486 is 2 to 3. So that same pattern, we get 256, C, 256, 3 to 2. Same themes, again, built into geometry, Pythagorean tuning, Pythagorean hammers and music, Pythagorean theorem. It's just all in here in this geometry, in the architecture, in the legends and the stories, and these things incorporated around wider hermeticism. And I'll pause a moment. I'll put the link in the description to this channel, the Ritman Library, which is a Hermetic library in Amsterdam. And through the university there, they've now have they're studying Hermeticism and the history of Hermetic philosophy. So I'll put the link in the description. But it's very interesting, very cool, because he's basically pointing out the fact that Hermeticism has got to do with the natural sciences. It was the what we now think of modern science emerged from these Hermetic traditions. However, we've lost our way a little bit because, as will be talked about in this particular the history of Hermetic philosophy in this video, how he mentions how music, astronomy, geometry, arithmetic, how these fields within the quadrivium and well science in a broader sense all come together, and it's Hermeticism is about bringing what we think of as science and philosophy, how they come together. And it's also interesting if you watch the rest of these videos on this channel, highly recommended, but also those who were opposed to it. So for instance, it was called either pseudoscience or pseudo-philosophy. And if you look at the people saying that, well, they're protecting their agenda. And unfortunately, like a meme, this, sorry to say, ignorant prejudice about what Hermeticism is has been has grown, unfortunately. And yeah, so much stuff in regards to Hermes Trismegistus is available on the net, but so little of it incorporates these very, very important points in regards to the sciences as we know them now, philosophy. They sort of go off on a Harry Potter tangent, let's just call it. Not that there isn't some aspect of that in there, I'm not going to, but it's more, well, the basis of it and the tangible elements of it rather than the more subjective interpretations of what it means. But again, Rittman Library, especially this particular little episode, History of Hermetic Philosophy, links will be in the description. Again, very interesting, highly recommended channel and videos. So we've seen weights and measures, music, geometry, astronomy, arithmetic, and well, stories such as flood stories, Epic of Gilgamesh, Inanna, just it just really goes on. So 256. So we'll have a quick look at this column, because for instance 2, 4, 8, 16, they're such common numbers that it's too easy to find a connection to them. So that's why I started with, because these larger numbers, it's it's to fall on those is now you have to. There's a probability, there's a higher improbability level that they would fall on these. But when it comes to 2, 4, 16, well, you're getting like such a small number, and well, yeah. So still, there's information in there, but I'll go over it quickly. So, for instance, earlier episodes in this one I mentioned how radio frequencies, screen resolutions, all this come around to fall on these numbers. Now, for instance, the old Macintosh 16-bit, Commodore 64, Commodore 128, and okay, I've got to pause, I forgot to include one. Okay, 8-bit or 256 color displays, but also 256-bit. Now it's interesting little, if you want to read a little bit further, because it didn't have to actually be like this. It's, as is so often the way, the organizations which standardize things such as ratios of screen size, radio frequencies, all the modern electronics, is they keep using these because these numbers are very, very powerful and they're very, very convenient. And for instance, 12-inch, let's say, look, I'm just going, just as an example, 12-inch foot versus the 100 centimeters of a meter. 12 inches I can divide it into thirds and get 4 inches. So 12 inches divided by 3 is 4. Also I can divide 12 by 4 and get 3 inches. So I can go into quarters, I can go into thirds. If I try and, what's 1/3 of a meter? 33.3333 onto infinity centimeters. So that's one of the reasons why these systems is very cool. But anyway, just as an example, because these numbers have so many divisors and they break down cleanly and they that's one of the reasons. However, the origins of this go back quite some time, and well, they had the same systems going on. Again, the Rittman Library, Hermeticism, the Gunther, all these people, they knew what they were doing. They built the standards that they set in place are the ones which still define our world today. even though as we move more to metric, still the 66 feet wide street and these type of things, but it goes back quite some time. So still in computing, how this is important, but in weights and measures. So 1 gallon is 28 fluid ounces US. I should have said specified US there as well. 64 piece like chess, but this is one example why I say these particular numbers are too common, because if so you get an idea. But also 64 hexagrams in the I Ching, it's a third dimensional number as well, 64. And 32, so 32 forms of Ganesh, 32 paths of Kabbalistic wisdom. The 32 degrees Fahrenheit is freezing or zero, which is 273.15 Kelvin, and 273. Portolan mapping, this old ancient mapping system, if you've seen these Peri-Reis map and the Laurentius Phineas map as well, and so many others, but before the longitude and latitude system we have now of mapping, this was the method, the Portolan mapping system. Again, it's a nice number across 3 dimensions as well. So that's just again, we just see these numbers they're very, very cool with this small, it's basically just built on 2 by 3 and then building up through the 2nd, 3rd, 4th dimension. And again, just carries through cultures, carries through time up until this modern. They're very, very important to the ancient sciences, but to the modern sciences as well. And again, still describe so important to our world today. And that's one of the importance of it. But also, again, how it, as in the link in the description to the Rittman library in the particular video, how it's about bringing multiple disciplines within the sciences together and try again to harmonize them under one field. It's like unfortunate, for instance, the education system I went to, you go to your English class, you go to your maths class, geometry, sorry, not even geometry, chemistry, and geography, but everything's so separate. So this is one of the beauties of this system, is that when you're doing your English lessons, you're also learning about geography. When you're doing your maths lesson, you're also learning about music. When you're doing your music, you're also learning about physics and all these. So that's why it's such a, within a very small selection of numbers, you get so much information, but it's all because it brings things together. And I understand it's because we've become so technological. If you specialize in creating circuit boards, there's so much information that you can't possibly consume all the new papers being published on biology or this field or that field. So I do understand that. However, I do believe there should be some trying to bring these fields together, because it's an unfortunate tendency that we want decimal numbers with a long string of after the decimal points, and again that's sciencey, but if you do it in this particular way, it's sort of somehow pseudo-scientific, pseudo-philosophy, or your fundamentalist religion or something. I don't. Again, there's a prejudice in regards to these things, and I'm glad that I encountered certain teachers and presentations which released me from this ignorant prejudice. Okay, so that's it for this compilation. This is, even though for the length it was a brief rundown of all the other aspects, I have hundreds of videos covering the US state capitals, some focusing just on Washington, a whole series on New York, but also Canada, Australia, Paris, London, these other places, and where you can see not just in the historic architecture, but it's still being applied in very special major public buildings, major monuments and sculptures, like the key ones, not just some random one in a park, but the prime positions. Banking and mining, the architecture of their skyscrapers, for instance, tends to be a hotspot for this type of thing as well, where so even with the modern skyscrapers, now some of them are just pure architecture, modern architecture, but there are key architects who get really important major public buildings, and who consistently use these sets of numbers. So even though the symbolism might not be there like in classical architecture, but it is still being applied as well. And if you leave in a comment, if you're interested, like your, especially if you're in the US, your state, your local city, chances are I've covered that, and you'll see how your major sculptures, monuments, etc. But also others, yeah, London, Paris, New York. There's a whole series, like Washington DC is a very special city. There is an equivalent here in Australia, that's Canberra, our capital city. The capital city of Kazakhstan is another, and Brasilia, or the capital of Brazil, is another, where you'll see this geometry, the symbolism, but that can be argued, debated over, but the persistent use of key dimensions in the buildings, heights, widths, and the numbers of the floors in these buildings as well. So that's a very important application. So harmonics, just like with screen resolution, monitor size and stuff, it's still being applied in the very modern sense, but it has some very, very ancient origins. And that's not just a matter of observation, because again, like I showed earlier on, Vitruvius being this key document applied as well, and Vitruvius was compiling older Greek stuff, and then where did the Greeks get their knowledge? Well, from Mesopotamia and from Egypt and from ancient India. You look at their sculptures, their buildings, the like 108 and all these harmonic numbers in the yugas, in the architecture itself. It's just something that is persistently repeated as well, and is reasonably well documented. Even some very old texts on the, oh geez, I forget the name of the fellow who wrote it, but he wrote the treatise on weights and measures as well. So it's weights and measures is so key to this. It's you can look at it in symbolic nature, but yeah, if you just by studying the ancient systems of weights and measure, there is a lovely story to be told. For instance, the ancient Indus civilization, Mohenjo-Daro and Harappa, were using the same weight system used by Old Kingdom Egypt centuries before there was recognized trade between them. The Varna culture on the Black Sea were using the Royal Egyptian cubit and this 4-3 geometry, 4-5-3 geometries a millennia before the early dynastic and just that Old Kingdom period as well. These are weights and measures. Now, also whether it's stone circles, dolmens, and such sort of mounds and old tombs, for instance, in Karnak in France, in Spain. It's a lovely system. Now, if you strip away any sort of, I don't like to talk about it, divinity, spirituality, or those types of features, at the very least in these harmonic numbers, you have an excellent system of memorizing and learning things. So you get grips with a number like 108 or 432 or 864. Geometry, timekeeping, weights and measures, astronomy, architecture, they're all there to be embedded. Now, whether there's a direct link, again, some will just don't want to know. I believe there is, by the documented records of architects like Vitruvius, and through to the Renaissance, when you had the re-emergence of classical architecture as well. And again, just weights and measure systems. It's there, and it's a beautiful system. So many applications to it, and what is ancient is modern, because it never really went away. So with that, I hope you enjoyed. Again, I've got lots of other videos on this, on specific locations, other ways of looking at these harmonic numbers. I think there's something hiding in the fourth dimension in regards. I've got a few videos on that. I might compile those together and do a compilation such as this and an update. So with that, hope you enjoyed, and have a good one.